Okay. Here we are. Oh, rats, I didn't set up my editor for today. Share my screen while I set up the editor. So, oops, wait, that's wrong. cd.dot. Now cp day 9. C day 9. Alright, now I have my editor, I have my files, I have my sample data, I have Advent of Code up. And I'm ready to start talking. So, okay, cool. Okay, sorry about for that delay. Here we go. It's a pleasure to be back. So, my name is Kent Quirk. I'm a software engineer. I've been doing this for a while. And I am solving Advent of Code problems. Advent of Code is a daily puzzle aimed at computer sciencey type problems, solving them live. Now, one of the things that actually was reminded about by watching somebody else's stream of Advent of Code was that this is it's kind of a race. There is a leaderboard for the top 100 people or so who finish the problems the fastest. And that's about speed of hacking and not, kind of engineering. It's just like how quick can you get an answer. So a lot of people do the problems as soon as they go live, which is at midnight my time. So I used to be the kind of person who coded at midnight. I'm no longer the kind of person who codes at midnight. So I'm not interested in competing for how quickly I can get the problem done. Still try to do it fairly quickly, but I try not to do it by like just hack and slash. It can be interesting how people kind of run down rabbit holes because they made bad decisions like 5 minutes ago. In my case, I try to apply some reasonable engineering principles without being ridiculous about something that's going to be thrown away in half an hour. So that's kind of where I'm coming at is try to make it clear, try to make it try not to make any bad decisions. Don't necessarily make all the best decisions. But anyway, that's my general concept. Now I will share my screen again, and we'll start getting into the problem. So I've got my editor set up on day 9, and now I'm going to see what day 9 is about. So this is not a continuation of the virtual machine of yesterday. I guess that's good. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you connect to it. Upon connection, the port outputs a series of numbers. The data appears to be encrypted with the Exchange Masking Addition System, XMIS, which conveniently for you is an old cipher with an important weakness. Okay, XMIS starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any 2 of the 25 immediately previous numbers. The numbers will have different values, and there might be more than one such pair. Okay, so that means that we're not adding up whether, 26 would be a valid okay, so I skipped a paragraph. For example, Imagine your preamble consists of 1 through 25 in random order. To be valid, the next number must be the sum of those two numbers. Sum of two of those numbers. So 26 would be valid, as it could be 1 plus 25, or 2 plus 24, whatever. 49 would be a valid next number. It is the sum of 24 and 25. 100 would not be valid. No two of the previous 25 numbers sum to 100. 50 would not be valid. Although 25 appears in the previous 25 numbers, the two numbers must be different. Okay, so 26 is valid because it could be 2 and 24, but it can't be 13 and 13. Okay, so suppose the 26 number is 45, and the first number, which is no longer an option, as this is more than 25 numbers ago, was 20. Okay, so now we have 1 through 19, 21 through 25, and 45 that add up to it. 26 would still be valid, 65 would not be valid, no two available numbers add up to it. Interesting. 64 and 66 would both be valid. Okay, here's a larger sample which only considers the previous 5 numbers. Has a preamble of length 5. Okay, so this one, so now it's the same problem but with 5 rather than 25. So 35, 20, 15, 25, 47. Alright, so let's consider that the preamble is a parameter. The length of the preamble is a parameter. I think we want to make sure that we don't assume that it's 25, because even our test data has a value of 5. So we're going to take our test data, copy it, put it in our sample data, paste that. Now, in this example, almost every number is the sum of 2 of the previous 5 numbers. The only number that follow this is 127. I'm not going to go through this, but we're going to test this to make sure that we find it. The first step in attacking the weakness in the Christmas data is to find the first number on the list after the preamble, which is not the sum of 2 of the 25 numbers before it. What is the first number that does not have this property? Okay. Let's get our puzzle input. Copy that. Paste that into input.text. Oh, these are big freaking numbers, and there's a lot of them. Interesting. Okay, just see how many digits we have here. I'm guessing, since these problems are intended to be tractable with things like JavaScript, which has an amusing 50... it's not a 64-bit integer, it's like a 52-bit float that can be an integer reliably up to like 52 bits. Anyway, it's a 64-bit float that starts skipping integer values once it gets to 52 bits. Anyway, these numbers all fit within 64 bits easily, so let's just assume that. Anyway, so we have an input file, all numeric, and this one says 25, but again, we're going to take that as a parameter. So let's close this one. So first thing we're going to do is parse this file. Data for underscore comma line colon equals range of lines. Let's data data is make of array of int slice of int, and we need it to be length of lines long, And then actually we can do an index here. Say n strconv. Oh wait, it's not happy with what I did with make because I didn't close the parenthesis. Okay. strconv.aui of line. If error is not equal to nil, log.fatal error. This isn't going to happen because the data is good. And then unless I have to stuff it in a long, well, let's try it. And then we can say data of I is n. And now, oops, we can parse that. So, cool. So now data is the item and input that text. So I'm just going to run this to make sure that it parses in run.go 47, which is the first entry in. Let's make sure it's the first entry in input that text. Yep. So we read the whole thing, and len of data. $47, 1,000. So there's 1,000 numbers in the list. Great. Okay. So now let's func day 09a, and it's going to take data as a slice of int, and it's going to return an int. So I'm also going to change this to input sample.text. Oh, and actually it's going to take, I'm also going to give it preamble is an int. That way we can parameterize that based on our sample data. So let's say the preamble is make a slice of int, which is preamble length in length. So we have preamble is essentially a short queue, and what we're doing is we're throwing away the oldest value. It's a FIFO. We're throwing away the oldest data and keeping the newest data, or adding a new item to it. In this case, the order in which we iterate this doesn't matter, but what we need to do is keep a reference to which one we're going to discard, and then we can replace as we get a new item. We overwrite the item is being pointed to at that thing, and then we move the pointer on and we loop it around and we get back to it. When we calculate the n-squared combinations of the addition, the sums, those will end up in, it doesn't matter what order we do those in. We can just do effectively a product of the list with itself. And it doesn't we can always start from the beginning of the list. We don't have to use that pointer to. We don't have to iterate the list in order. We just have to iterate the list. Anyway, so this is an interesting problem from the point of view of, I'm not sure if there's no optimization of this has popped into my head yet. There may be, like, I think it's probably just easiest to iterate the list as an n squared thing and quit as soon as we find the item, as soon as basically adding up all possible pairs, and if we get the answer we're looking for, then we say, yep, we're done and we can move on. I don't think we have to do more than that. It may be that that the complexity of this gets raised a lot, and so the processing time may take a long time. But this is Go, so I'm kind of hoping we're not going to run into that, and that I don't have to think any harder than this. So let's just say the preamble is that. Let's fill the instead of making it in and then filling it explicitly, we can just take it by the preamble line. We can take a sub slice. Oh wait, this is Go. We can make the preamble each loop. All right, so Go slices our view onto a larger backing array, and you can create, using slice notation, create a sub-slice effectively. And so actually it's going to be faster for us. Instead of having a new array that we keep replacing values in, let's just make a slice which is a window onto, it's a moving window onto the total that we have, and then we can iterate based on that, which is going to be probably somewhat faster. So let's do this. Let's just do our index. We'll call it start, and that is in the range of data minus preamble length. No. Yeah, instead of doing range, we're not going to do a range here. I'm just going to do a basic iteration loop. So start equals 0. Start is less than length of data minus preamble length. Start gets incremented. And our preamble is now data from start to start plus preamble length. So that is a slice of our big slice. And now we can write our loop. So for I I'm going to do these indices as I equals 0, I less than preamble length, I plus plus, and then I'm going to do another nested loop of okay, see, this is what happens when you use other programming languages. You leave the parentheses in that you don't need. For j is 0, j is less than preamble length, j plus plus, and if I equals j, we're just going to continue. Oh, wait. no, this is wrong. We don't have to do order independent product of all of the values, because this is addition we're talking about. Addition is commutative. So actually I can start j at I plus 1 and leave off this conditional. So for j, so j starts at I plus 1. And goes to the end. So that's all possible combinations. So if I have 1, 2, 3, 4, 5, I can then do 2, 3, 4, 5 for j. And if I get, once I gets to 3, I can just do 4, 5. So we're basically doing half the triangle of this. It basically, if you think of all the elements in the list as, you know, both as an array of both x and y, we're basically doing the top half of the triangle excluding the diagonal. So, sorry, my dog's going nuts again because there's probably a delivery person here. So it happens. All right, so now we've got I and j, and we can say sum is the total of preamble I plus preamble of j. I guess, yeah, we're trying to see. This is going to start up. Hold on. All right. All right. So my outer start loop starts from 0 and goes until we get to the actual, where the only thing left is our preamble. There's nothing else to check. So in this case, we are going to we're going to be checking, the value we're checking is the value at preamble length. So if data, oh wait, start plus preamble length, start plus preamble, start plus preamble length equals sum, we have determined at that point that this is a valid value and we can continue. Now the thing we're going to continue is the outer loop. We don't have to check any of the inner loops anymore. As soon as we find one combination that adds up to the value we want to quit. So we're going to continue, but what happens if we just put continue here? We're going to continue the inner j loop. And so how do we continue an outer loop? In Go, you put a label on that outer loop, and we're going to call this outer, and then we can say continue outer. So that means go all the way back to the beginning and continue that loop. And now that conditional is done, that for loop is done, this for loop is done. And if we get all the way to the end here, without having continued, then we can return. The value we need to return is the one that failed. The thing we were testing, the value we failed, the value that failed is the value we're testing, which is start plus preamble length. So we're going to take this, copy that, and return it. All right, so let's do this. For the input sample, we're going to day 9a of, and we're going to pass it 5, which is the length of the preamble, and data. And we're going to see whether we get, the value we should get is 127. So let's see if this works. Oh, what did I do? Oh, I guess it doesn't realize. If we got to the end without having returned anything, then it means that our algorithm failed according to the rules of the puzzle. But let's just do that. See what we get. 14. Okay, that's wrong. What did we do wrong? So, oh, sum is preamble of I plus preamble of j. In the sample data, I just want to check to make sure our sample data. Oh, no, it's the 14th value that we returned. So it's not this, it's data of that. So it's the index that we just returned. And let's try again and see if 127. There we go. Okay. Yes, so it was the 14th number in the list is the bad list. So looks like the algorithm's correct. So now let's try it on the real data. So here we have to make 2 changes. We have to delete the sample, and we also have to change this to 25. And so that's the number it found. It didn't seem to take a long time. That brief pause was due to compilation time, I think. So I'm not going to worry about how performant it is right now. Let's just... I'm going to just search to see where that number occurs in a list. $611 items in the list. Seems plausible. Okay, so let's try it. Let's see if that is the answer that they're looking for. Submit. That is the right answer. Yes. Okay. Continue to part 2. All right. Final step in breaking this, it relies on the invalid number you just found. You must find a contiguous set of 2 numbers which sum to the invalid number from step 1. Oh, fascinating. Okay, so now it's asking us to look at the list and find the set of numbers in the list that could add up to this. So, and it could set of consecutive numbers. So now I have this sum. I have this concept of a range within my big list, and I basically want to do a moving window of that range and find a subrange that is that sums to this particular magic value. So the magic value. So what we're going to do is we're going to use the same technique we just used to get a subrange of the list and sum a subrange, and we're going to start with a short subrange of 2 items and then work our way, just keep increasing the thing and running the thing through until we get the range that actually contains, that sums to the right total. So we have this slice of numbers. So first, func D9B let's do this. Since we know that our magic number is that. Println magic. And then day 9b, this is no longer preamble length. This is now magic. And we still have the same data. And so now we want to find a window in the data that adds up to the magic number that is at least 2 elements long. So we're going to we're going to do the same sort of start loop here. Actually, we're going to have even an outer loop. So I'm going to call it window size. And I'm going to say for window size is starts at 2. Window size is less than length of data. We're never going to hit this if we solve the problem. It's going to be presumably much shorter than 611, but you know, we'll potentially iterate the entire list. Window size plus plus. That's our outermost loop. And then we say, all right, so starting at 0 up until we run into the end of the data. We want to sum a range, and I'm just curious as to whether sum wait, I need go. Okay, there's no sum of an array feature in Windows. There is in many other languages, but I mean Windows in Go. Let's do this. So we just have to iterate over range. So, but actually, let's write one. In this case, it's going to be better for us to say func sum, and it's going to take a slice of int range. Just a, which is a slice of int, and for for underscore comma I colon equals range int this has to be an int total is 0 total plus equals I sorry, my editor is being a bit annoying. And then we're going to return total. Okay, so that gives us a little bit cleaner. If sum of data starting at start and going up to start plus window length, window size magic then return data start plus data of start plus window size -1. What they said is add the smallest and largest values. Smallest and largest number in this contiguous range. So this is an interesting one, because these values aren't necessarily sorted. Oh, so they want me to sort this list first. Okay. Let's just... Alright. So first we have to get the result. And result... so we have to create a result. So result becomes the... is a make. We're going to make a copy that we can sort. So we're going to make a copy of. We're going to make an array of it, slice of int, and its length is going to be window size. And then we're going to copy into that result. So we're going to copy. Now, copy is a built-in in Go that can copy slices, and it's destination source. So we're going to copy into result the range that we've just dealt with here, which is this. I guess I probably didn't even need to specify window size here, right? I think copy would work without it. I'm going to leave it there for now. Maybe I'll test it later once I see this is good. And then we're going to return the... and instead of data now, we're going to return result of 0 and result of window size -1 added together. And if it turns out that we got all the way to the end and never found it, we're going to return -1 again. So that we have a pretty good idea of what's going on. What was I thinking here? For I... Okay, that's a little better. I see no other errors. This looks like it's possible. So there's magic. Let's change this to a printf. And then day 09B magic and data. So let's do it again, the sample data again, just to prove that we got it right. Sample, and then this number becomes 5. And all right, my weakness is supposed to be 62. So let's find out what we did wrong. Print result, println result. Why is this an error? Oh, because I haven't created it yet. before we... Oh, we didn't sort result. The whole point of this was so that we would sort result. Silly me. Okay, so sort dot ints. See, because we're working with ints, Go has a built-in sort thing for it, which is handy. You have to work a little bit to make it work otherwise. And I didn't sort it until I sorted it too soon. Let's try it again. That's better. Okay, there's the result. And now we're going to go back to doing this to input.text with a window size of 25. I'm actually curious. Just what the window size is going to be, because this worked. 17. Okay. I mean, that ran so fast it didn't matter. Obviously, we're doing some fairly hefty iterations. If we had done this in a slower language... Actually, I think this is probably fine. Even if we had done it in Python, it wouldn't have taken long enough to matter. Sometimes these Advent of Go problems can be computationally quite challenging. I do remember one that a naive solution ran like 3 hours, and I had to really put a lot of effort into thinking of a smarter algorithm in order to solve the problem. But so far we haven't run into that. So we have, I say we've successfully solved the problem. We have to prove that we've successfully solved the problem by putting that weakness in and submitting it. That is correct. Okay, we did do it. I was so confident. So yeah, there we go. Let's delete the Python solution. I'm not really spending any time on the Python solution these days. If anybody really cares about that, then yell and I will try to do it. But for the most part, I'm here to kind of focus on sort of software engineering in Go. So let's just do this. Solve day 9 in Go. Oh, yeah, it actually helps to stage your changes before you commit them. Let's hear it for and then let's push this back up so that people can see it. Cute trick for those who don't know it, in Bash and Z Shell at least, Control R does a reverse search of your command lines. So if you type Control R and then push, you can find the last time you pushed anything, and in your command list, history that's still hanging around. Yeah, so anyway, that's up on GitHub. So yeah, we're done. My name is Kent Quirk. I've been doing software engineering for a long time, and I am just kind of go through these problems and solve them with hopefully reasonably well understandable Go code. I'm trying to be here every day for the advent of code, and I'm not trying to race for the solution of the advent of code. I'm trying to do something that's maybe slightly more considered than just a quick hack. I am hoping you enjoy this, and let me know if you need anything. Hit the follow button. Leave me a note. Drop me a line. I'm Kent Quirk on all the social media things. except Facebook. I don't do Facebook. And hope to see y'all sometime. Thanks for watching. See ya.